Hello, today we are going to revise solving equations, so make sure you get that title down in your book, and then I'm going to do a worked example, then it'll be your turn. There's actually two methods I'd like to go through. We're going to start off with equations with brackets. So the first worked example is, let's keep it in purple. So I'm going to go through this one without talking first of all. Undivided attention on what I'm doing, see if you can follow it. And then I'll talk through it and annotate it, and then you can have a go at the your turn question. So first of all, okay, so final answer of x is -1. So don't be afraid of getting minus numbers or fractions or anything like that. Anything's possible really. And I can double check I got it right by subbing x is 1 back into this. Well, if x is 1, then I've got 4 times -1. So that's -4, add 10, which is 6. 6 times 2 is 12, so that equation adds up. It makes sense. I know I've got it right. Few things I want to know and we should be familiar with is making sure you're doing the same thing to both sides, which I know we're really good at. I know some of you like to do the arrows as well, so you can add in arrows each time, not necessarily in highlighter. And a key thing to remember is I'm always doing the inverse. When I'm getting down to solving equations, I'm doing the inverse, because inverse of adding 20, taking away 20. I've got to do it to both sides to keep the equation balanced. Inverse of timesing by 8, dividing by 8. Just a note on my first step then, this was expanding brackets, and we were pretty confident on that before. I think we did it maybe towards the start of the year or maybe in February, but we were really good at it, so I didn't feel like I needed to go over it loads. The other way to do this, and the other way we learned in class, was I'm going to do exactly the same question, but I'm going to do it slightly differently. Maybe you can think, oh, what could I possibly do here? Well, so notice I've got to the same answer, but my first step this time was different. I divided both sides by 2. Because this expanding brackets means that I'm doing 2 multiplied by this thing here. Well, if I divide both sides by 2, then that gets rid of this 2 here, and we divide the other side by 2 to get 6, and then we're just left with what would be in the brackets here because we've divided all of that side by 2. That only really works, or it will always work, but I think it's easier to do that when the number on the right hand side, so let's put a circle around it, the number on the right hand side, or this number, is easily divisible by this, meaning that 12 divided by 2 is easy to do. It gives me a whole number of 6. But say this number was like 50 and this number was 3, then I'd get 50 over 3 and I'd start to work with fractions. So I think it's easy if this is if the number in front is a factor of the number on the end, then you can just divide, but otherwise it's probably easier to do this first method here. Right, for your term, I would like you to have a go at. So make sure you get them down in your book, both methods. I would like you to have a go at that question. Okay, so pause the video, have a go at it. You can choose whichever method you prefer. I'll do both, and then you can just double check if you got them right. So I'll do the first method here. So I'm happy with just leaving my answer as a fraction like that, 9 over 8. I could, or minus 9 over 8 I should say, I could write it as a decimal as well, which would be minus 1.125, and I'm getting that from my calculator. So yeah, you could probably work it out as well. Okay, so I'm happy with that answer. Don't be scared of getting negative fractions or negative decimals. Anything could happen really. So I'll just show you the other method as well, just for those that preferred the other method. Now this is a situation where 2 is not a factor of 11, so I'd probably pick the first method. But you can still do it this way, because if you divide both sides by 2, let's make sure I'm noting down that, then I've got 11 over 2 here, which is 5.5, just 11 divided by 2. Take away 10 from both sides. And this is why I'd probably use the first method, because you may need your calculator at this point. So that gets me minus 9 over 2, or minus 4.5. Divide both sides by 4. And we get x is equal to minus 9 over 8 again. So you can see we're still getting the same answer. But I just think the first method's a bit easier in this case because 2 is not a factor of 11, so we end up with a decimal here. So make sure you get those down in your book. Any questions about any of that? If you want any further explanation, then just email me. Right, the next thing we're going on to is equations with negative x. So I'll do exactly the same thing again. I'll do a worked example. You watch it, get it down in your book, and then you'll have a go at your turn. So the first one is so the reason it's an equation with a negative x is because I've got a minus in front of my x term there. So there's two ways to do this again, so I'm going to split it out like I did last time and do a dotted line here, and then I'll show you both ways that you can do this. So I'll just do it silently first and then I'll talk through it. So we get a final answer of x equals 4. The first step here, I don't really like dealing with negative x's. So to make it positive, I can add 2x on this side and add it on this side because I'm doing the same to both sides. And then I've now got a positive x term here, which I like dealing with better because it's the thing I'm trying to find. It's a bit handier to have it as a positive. Then I took away 10 from both sides because it's not always easy to see when there's no sign in front of what the inverse is. But if there's no sign in front, it'll mean it's positive. So the inverse of, we want to get this x on its own, so take away 10 from both sides. Then we're down to something we should feel comfortable with, of dividing by 2, because we're 2 and 2 times x. Inverse of that is dividing by 2, and then we get x equals 4. Right, I'll show you the other way to do this as well. So same question. So this requires quite a good knowledge of negative numbers. So this time I left my 2x on this side and I kept this. It has to stay with that negative because it's negative 2x. But my first step this time was to take away 18 from both sides, because this is as I said before, if it hasn't got a sign, it's positive. So the inverse of that is taking away 18. Take away 18 from 10 and I'm going to get negative 8. So I can see I've got two negatives on this side. To undo, well, this is saying negative 2 times x. So the inverse of that is to divide by negative 2. If I do negative 2 divided by negative 2, then I get positive 1. So that's why I get a positive 1x here. Negative 8 over negative 2. Negative divided by negative is a positive. So that's how I get my answer of 4. As I said, that requires good knowledge of your negative numbers. Right, get those both down in your book, both methods, decide which one you think you're going to use. I generally prefer to use the first method just because I think it helps later on as well when you get more x terms and you think, right, let's make x positive. So my preference is 1, but it's good to be able to do both, really. So your question is, so maybe we could do a little reflect, expect, check here. What's changed? How's that maybe going to affect what happens? Notice this stuff is now on the right hand side. Does that impact what you're going to do? Pause the video, have a go at it. I'll go for it now. So we've got a final answer of x equals 2. So there's your first method. Second method would be so obviously both ways we do it, we're getting the same answer, which is a good sign that we've done something right. But again, you need good knowledge of negative numbers here because you're doing 10 take away 18 and then you're doing negative 8 divided by negative 4 and negative 4 divided by negative 4. So it does require good knowledge of your negative numbers. So make sure you've got all of those down in your book. The thing I really want to stress that is so important with solving equations is showing your method. So what are you doing to both sides each time? And some of us like to show those arrows, as I said before. What are you doing to both sides? Doesn't have to look exactly like mine, but just make it really clear to me, to yourself, to an examiner. What are you doing to both sides? It will really help you in your work, and you'll find you get way more stuff right if your workings are clear. Not mentioning any names for who that's aimed at there. Right, what I'd like you to do now is have a go at these 8 questions. I've provided the answers in this box here, but they are in a jumbled up order. Notice that when you could leave your answer as a fraction or a decimal and you should still see that it's the right answer. There's a couple of 3s and a couple of 8s, so don't be put off by that. They are there on purpose. You should get the two questions in there where the answer is 3 and 2 where the answer is 8. Notice I'm giving you the answers. I don't care about your final answer. It's how do you get there. I'm actually giving you what the final answer is. You could write these answers down in your book and it wouldn't make a difference. What I'm interested in is how do you get there. There is one red herring in there. So there's there's 9 answers and 8 questions. That's just so when you get to the last one, it's not just, oh, it must be that answer. It's just to keep you going with it, really. Make sure you have a go at those in your book. Any that you are not sure on, so you're like, I do not get any of the answers in this box, and I'm not sure how you get to those answers, then please email me. Have a great day.